Okay. Here we need to show that we can handle interrupts, and as well we need to use indirect addressing. So if you're not completely comfortable with those two concepts, please revise the notes. So we'll be using interrupts and indirect addressing. And in particular, we'll be using the LD instruction. Please revise that. So in this particular problem, we are going to be doing some output to port C. And we'll be using interrupt 0 in toggle mode. There's nothing in here that requires interrupt 1. There's nothing here that requires PC int at all. And there's absolutely nothing here that requires a timer. So first thing, if you are using an interrupt, is to set up the interrupt vector table. So here we have to have the entry for the main reset. That's the main loop. And then interrupt 0, the entry is, if you look at the data sheet, is at position 1 in the interrupt vector table. And so we will jump to int 0 handle. So the main section of code does the setting up. We need to output to port C, so we need to convert port C into output mode. So we'll load R16 with FF, and then we output to DDRC R16. Then we need to enable interrupt 0 only in toggle mode. So we'll first of all set up the toggle node for it for interrupt 0. So I'm going to load into R16. The following expression. You'll see that we need to put 0, 1 in the appropriate bits of the EICRA register, and this is the best way of doing it. There are people in their answer who set up a bit pattern over here. This is a much better solution because it's portable across multiple devices. Whereas if you just put a bit pattern that works for one device, it may not work for another device. So it's much better to do it this way. And then we will output that value into EICRA. Then we need to set the masks up correctly. So we will say load into R16. I want to enable interrupt 0. I don't want to enable any other interrupts. And then I'm going to output into EIMSK R16. And that's going to set up the interrupts. I also need to do a global, set up the global, set the global interrupt flag, but I'm going to do that. It's always good practice to do that as late as possible in your code. The final thing that I need to do in the main section is that the instructions say that we're going to output values from 600 through 620 in turn. And the easiest way of doing that is through indirect addressing. And I'm going to use the Z register. You could use the Y register or the X register as you prefer. So I'm going to set up the X register, which has to be done in two parts because it's an 8-bit register. You can't do it in one instruction. The high byte gets set to 20, so the low byte gets set to 20 and the high byte gets set to that, not 60, sorry, gets set to that. And finally, now I'm ready to enable the interrupt. And then I go into our sleep loop. We also need to set up the interrupt handler. So we have our interrupt 0 handler. And this is what we have to do, is just put out onto port C. We have to put out onto port C the numbers that are stored in locations 600 to 620 in turn. And I am going to do this by doing the following. I'm going to use indirect addressing. So load into R16 Z plus. So this says load into R16 the number that can be found in memory at the location specified in Z. Initially, Z will be 620. So this says load into R16 what's stored in location 600 in memory. Also, once you've done that, add 1 to Z. So Z becomes equal to 621. And finally, I am going to output onto port C R16. The final step is to put in a return from interrupt, so that once the interrupt handler has put out the latest value from memory onto port C, we can go back to wherever we were in the main loop. The other good thing to do, which would be a bonus, would be to have a counter here to make sure that this is done exactly 21 times, from 600 to 620. And then once it's had been done 21 times, then you would perhaps go to the end and terminate the code. But that would be a bonus for what I would expect in the test. Apologies, one minor bug I found in reviewing this answer is this point over here. The EI mask is not a special register, and we need to use STS rather than out to set the mask appropriately.